So we continue our look into logic with looking at compound statements. So that's when we're combining more than one idea together, and we're going to look at all the different ways that we can combine these ideas. So the first thing I want to do is fill out this chart so that we understand the symbolic relationship between these things and how it actually is expressed. So let's pick a letter and have that represent a statement. So I actually picked two statements. P is going to be representing mint is an herb, and then Q is going to represent basil is an herb. And I might have just picked these statements because those are some of the things that I'm growing on my patio. But anyway, in symbolic form, when we have negation, we symbolize that with that tilde with our statement. And the way we say it is we say not P. So this symbol we would say not P, which is the expression, right? Not P. So if I were to say that for this statement, I would say mint is not an herb. Okay? If P is true, then not P is false. If P is false, then not P is true. A conjunction is the combining of two ideas with this symbol. So we would say P and Q. This symbol represents and we would say P and Q. With these two statements, we would say mint is an herb and basil is an herb. The reason why symbolic logic is really nice is because we can shorten these statements to these symbols. So it would kind of be annoying to have to write out mint is an herb, mint is not an herb, mint is an herb and basil is an herb. Mint is an herb or basil is an herb over and over and over again. And so representing this with symbols allows us to shorten that amount of work, which is typically what mathematics is all about, trying to make things shorter and symbolize things in a more general and short way. A disjunction is an or statement. It is represented with this symbol, and we say P or Q. Okay, so in this case, we would say mint is an herb or basil is an herb. Now, there are two types of or statements, and I want to make sure we are very clear on what we're talking about. We are talking about the inclusive or. Okay, an exclusive or, if you read the chapter, they give you an excellent example. If you, let's say you committed a petty crime and you went to court, and at the end, the court said, I sentence you to 1 month in jail and a $100 fine. You would have to do both of those things. If the judge said, I will sentence you to a month in jail or a $100 fine, that is an exclusive or. He's only doing one or the other. An inclusive or, their example that they give is, let's say you are at a restaurant and you are ordering lunch and your meal comes with a soup or a salad. Your waiter or waitress might come up and say, would you be interested in the soup or the salad? You have the option of having the soup, you could have the salad, or you could say I would like both. So that's what we're talking about when we're talking about the inclusive or. It's not exclusive. It's not one or the other. It's one, the other, or both. Okay, that's what we're talking about with the inclusive or. A conditional statement is known as an if-then statement. Okay, and the way we represent that is we would say P and then the arrow and then Q, and the way we say it is if P, then Q. An example with the ones that we have might not be very clear in the truth value to it, but if you were to use this as a conditional statement, you would say, if mint is an herb, then basil is an herb. There are two parts to the conditional statement. We have the antecedent, which is I'm going to put in purple, that's the antecedent. And the part that follows is referred to as the consequent. What's interesting is that within all these types of statements, you can also have compound parts to it. So you could have a conditional statement where the antecedent is a compound statement. So you could have like, I'm going to write it down here in a little blue cloud and then we'll erase it. But I could have P or Q, and we put that in parentheses. If P or Q, then not P and Q. Okay, so in this case, the P or Q is the antecedent, and the not P and Q is the consequent. So P or Q would be your antecedent, and not P and Q would be your consequent. And then we have what's called biconditional statements. And mathematically speaking, these are your if and only if statements. So if and only if. Sometimes we shorten that to IFF, okay, if and only if. But the way we show that is P if and only if Q. And it's biconditional, so it goes both directions, two directions. It's read P if and only if Q. So mint is an herb if and only if basil is an herb. We'll find out later that if and only if, or P if and only if Q, is the same thing as if P then Q and if Q then P. We're going to take a few minutes to translate some sentences and statements. So let P and Q represent the following statements. P is the heater is working, and Q, the house is cold. We're going to express the given symbolic statements in words. So the first one is not P and Q. So we're going to negate P, so that would be the heater is not working. And then this symbol is our and. Then Q, the house is cold. Okay. Now we're going to do P or Q, so that neither of them are negated, so it's just the statements that they are, and we have the or, so this is going to be the heater is working, or the house is cold. So these are a couple of examples. Let's continue and look at a few more. So this one we have two statements. P is representing I'm leaving and Q is representing you're staying. And we're going to take each compound statement and we're going to write it in symbolic form. So the first one, A, is I'm leaving and you're staying. So that is an and statement and nothing's negated. So that's just going to be represented by P and Q. That is a conjunction. Okay, the second one is I'm leaving and you're not staying. So we have a conjunction again, we have an and statement. The first part of this, I'm leaving, is the same as P. So that first part is just P. The conjunction makes it, and the and makes it an and statement. So we use the caret symbol. And then you're not staying, well, that's a negation of Q. So we would say P and not Q. Then for C, and again, that's also a conjunction before I move on. Okay, for C, I'm not leaving or you're staying. So we have a disjunction because it's an or statement. We have a negation for that first part, I'm leaving, it becomes I'm not leaving. So that's going to be not P or, and then Q is you're staying. It's not negated, so that's just not P or Q. And then lastly, we have you're not staying or I'm not leaving. So we have not Q as our first starting point because it's this you're staying, you're not staying, it's negated. Or, which is a disjunction, I'm not leaving, that's a negation, so that'd be not P. C and D were disjunctions. Let's do the same thing for 3. We have let P and Q represent the following statements. Write each compound statement in symbolic form. P, the campus is closed, and Q is it is Sunday. And so we have if the campus is closed, then it is Sunday. So that's if campus is closed. So if P, then it is Sunday, Q. Then we have it is not Sunday if and only if the campus is not closed. So it is not Sunday, so that's going to be not Q. If and only if, that's a biconditional, the campus is not closed. So we have negations on both of these. Okay, let's look at this one. Let P and Q represent the following statements. Express each as each of the symbolic statements in words. So we have P represents the heater is working and Q is the house is cold. So we have if P, then Q. So if the heater is working, then the house is cold. Again, that's just our regular old conditional statement. Now, this next one is actually kind of tricky because it's a conditional statement within parentheses, but then it is negated. So it is a negated conditional, but we would think of this as a negation. So one way to represent this is we would say it is not the case that if Q, then P. If the house is cold, then the heater is working. Again, you might say it is not the case that, or you might say it is false that if the house is cold, then the heater is working. Okay, so it's negating this whole statement. So this part negates this whole statement. This last one is another conditional. We have if not Q, then P. So this is a conditional with one of the statements being within this compound statement being negated. So to write this out, we would say if the house is not cold, to get that negation in there, then the heater is working. You can see examples of where we take the sentences or statements and translate it into the symbols, and we can take the symbols and we can translate them into their actual statements. We have to watch and pay attention to the parentheses. So let's take each of these statements. P is Romeo loves Juliet, and Q is Juliet loves Romeo. And we're going to represent each of these given symbolic statements in words. So we're going to take the symbols and translate it into the words. I'm going to suggest that you try this on your own. So I'm going to suggest that you pause and then play in about 2 minutes after you figure them out, and then compare your answers with what we have here. So hopefully you'll get the same things. We have Romeo does not love Juliet and Juliet loves Romeo. That's that first one, not P and Q. The second one is Romeo does not love Juliet and Juliet does not love Romeo. That's not P and not Q. And then we have the last one where it is not the case that Romeo loves Juliet and Juliet loves Romeo. So notice the kind of nuance between each of these statements. They're very different if you think about it. Okay, let's do the same thing here. We can have compound statements that are built into compound statements. So we have 3 statements here, P, Q, and R. P represents the temperature is 85 degrees. Q is we finished studying. And R is we go to the beach. So we're going to represent each of these symbolic statements and translate them into the words. So the first one, what kind of statement is it? Well, it's a disjunction, because we have 2 parts that are combined together with an or. So this is a disjunction. But one of the statements is a compound statement, which is a conjunction. So this gets complicated. So this is a disjunction. Let's write it out in words. We would have P and Q. So the temperature is 85 degrees and we finish studying, or we go to the beach. So the big thing with this is thinking about how do I actually group this statement together, this and statement together. And the way that we do that is we use commas. Commas in English and in language group things together. So what's tricky about this is because it's not going to follow our grammatical rules that we know. Okay, you're going to want to put in commas that shouldn't be there unless you're grouping things together. So you might say, in this case, we have the temperature is 85 degrees and we finished studying going together. So let's write that. And then to show that or we go to the beach, we're going to put a comma there and then say or we go to the beach. And again, this is an example of a disjunction because our operator between the two parts is an or. So this is a disjunction. It's an or statement. Now we have an and statement within one of our pieces of that disjunction, but it is an or statement. It is a disjunction. This next one, we have a conjunction because our symbol between the two different parts is an and, so that's a conjunction. It's an and statement. Let's write it out. I'm going to suggest that you do the same thing where you pause, and I'm going to do the next couple on my own, and you compare your answers with mine. So the second one, we have the conjunction that we already went over. And we got the temperature is 85 degrees, comma, and we finish studying or we go to the beach. So that's how we separate that to the two pieces in that conjunction. Okay. The third one is a conditional statement. The first part is a conjunction, but it is a conditional statement. So we start off with if. If the temperature is 85 degrees and we finish studying, then I forgot an in, then we go to the beach. So those kind of inherently get grouped together just by the nature of an if-then statement, okay? Because we have those clear two separate parts. If this thing, and in this case, this thing was a conjunction, then this thing. So the last example is a conjunction that is an and statement. The first part of it is P, and then the second part of it is a conditional. So we start off, the temperature is 85 degrees, comma, and if we finish the studying, then we go to the beach. So get some practice writing these out and take the words and change them to the symbols. So remember that the temperature one was our P, that was the 85 degrees. The Q was finishing studying, and the R was going to the beach. We have those three statements. Now we're going to translate the sentence into symbols. If we have not finished studying and we go to the beach, then the temperature is 85 degrees. So we have an if-then statement. Okay, so this is a conditional. But in the first part of our conditional, we have a conjunction and we have a negation. Okay, and then we have that last statement. So our first part of this is going to be in parentheses. Let's do that in purple. If we have not finished studying, so not Q, and R, that we go to the beach, then, so if not Q and R, then the temperature is 85 degrees. That's just our P statement. Okay. The example B, we have the temperature is 85 degrees, and if we go to the beach, then we have finished studying. So this is a conjunction. We have that and statement there. We have it grouped, so the first part is just the temperature is 85 degrees. We've had that, that's just our P. And in the second part is an if then. And so we have if we go to the beach, which was R, if R, then Q, the finished studying. Let me double check my letters on that one. Yes. Okay, just making sure. Okay. So, so the next thing we're going to look at is the dominance of connectives, and we're trying to determine almost like an order of operations, but when it comes to logic. So it's the same kind of idea, like which one is the most powerful. So we know that in order of operations, we do the most powerful thing first, and then that would be like our parentheses. So in this case, when we have an ambiguous statement like this one, not P and Q, then not R. Is it a negation? Is it a conjunction? Is it a conditional? We can't leave this to be ambiguous. We need to either we have the parentheses put in there for you, and then it's very clear, like in the previous examples we saw, or you need to follow the order of dominance. So we have least dominant to most dominant, and the most dominant has the last say. So if they don't provide the parentheses for you, you're essentially adding them on your own. So the least dominant, I guess, operation you could think of it as in logic would be negation. Okay, this only applies to the thing that is immediately next to. So negation is the least dominant. Conjunction and disjunction have equal value, and we must indicate these with parentheses. Conditional are compound statements except for the biconditional ones, which are considered in parentheses. And then biconditional are compound statements on either side, and they are considered to be in parentheses. So if parentheses are not provided, we consider the most dominant connectives to be the ones that have the last say. So those are the ones that we would evaluate last. So if we had this statement right here, if I add grouping symbols based on the dominance, we would say that this is P. If P, then Q and not R. Our least dominant is at not R. The conjunction is next, and then the P, if P, then the other statement is our conditional. It's the most dominant. It has the last say. So this is a conditional statement. The next one, we have P and Q, then not R. Again, this would be a conditional statement. We would want to put parentheses around P and Q. If P and Q, then not R. That's conditional. Okay. This one, P, if and only if Q, then R. Most dominant part of this one is this biconditional right here. So that would mean we would need to put this in parentheses. So we write that as P, if and only if Q, then R. And that would be a biconditional. Okay, same thing with this next one. The biconditional is our most dominant. So we'd have if P, then Q, if and only if R. And this is a biconditional. Okay, so the most powerful connective is the one that determines these statements. This next one, the most dominant connective is that conditional. So we put that conjunction and the disjunction in parentheses to make this more clear. So P and not Q, then R or S. And this is a conditional. Conditional. I can spell sometimes. Conditional. Okay, this last one, we would say this is ambiguous because it would depend on where the parentheses lie. So if it's like this, you would say P and Q or R. Which means that this statement is ambiguous because if I had parentheses here, it's a disjunction. But if I had parentheses here, it's a conjunction. So you'll see the parentheses when you need them. Okay. Last few, I'm only going to do 2 of them. In this case, we're going to determine what kind of statement it is. We're going to put parentheses as needed before and after the most dominant connective. And we already have these same statements as before. So the most dominant connective is the conditional arrow. And so we need parentheses around this disjunction. So writing this conditional statement, we would have If we do not go to the beach, then the temperature is not 85 degrees or we do not finish studying. So you can see that this statement is a conditional statement. Okay, the next one. We have the conditional in parentheses, so therefore that's the first part of this disjunction. So when we write this out, remember we have to be careful with our commas. Now this one reads a little weird, but if we did not finish studying, then we do not go to the beach, or the temperature is 85 degrees. So this seems a little nonsensical, but that's how we translate that. So I'm going to post additional practice. You have the homework that you have to complete on these sections. There is a part 1 and a part 2, so make sure that you finish both. If you have questions, please make sure you email me. Thank you.